Yep, great. Awesome. Got a few people tuning in now. That's great. All right. um, I'll just give it another 30 seconds or so. Make sure everyone who wants to can get in. While we're waiting, shout out to my mate Kent at Northeast Link in Melbourne. 3D printed spreader bar. I was pretty impressed with that. Nice little gift I received recently. All right. Let's get moving then. I think we've got enough online. I don't want to hold anyone up tonight. Meant to be, good short, sharp session that hopefully you get a little bit out of. So to start off, let me introduce myself. My name is Liam Edwards. I'm the founder of Crane Class. I'm a heavy lift engineer who, I guess, transitioned from planning and executing lifts into founding Crane Class and helping people, teaching people how to plan and execute lifts safely. So tonight we're just going to go through the absolute fundamentals of load charts, but you should get a bit more out of it as well, that other than just understanding that we have boom length, radius, and capacity. You should get a bit extra out of it tonight. We'll go into telescopic boom sections, different types of load charts, and even go through an exercise of sizing up a lift. So let's not wait around any longer. Let's move forward into it. I can't see the chat while I flick over to the presentation, but if you do have questions, feel free to put it in there. I'll check occasionally. Otherwise, there'll definitely be time for questions at the end. All right. First of all, what is Crane Class? So Crane Class, we're Australia's leading training provider for heavy lift activities on Tier 1 construction sites. That means that our goal is to empower construction professionals, and that's people from site engineers through to supervisors and health and safety personnel, as well as operators and riggers who are interested in this type of training with the skills they need to plan and execute heavy lifts safely and confidently. And we exist because lifting operations are no doubt one of the highest risk activities on a construction site. And the truth is that most construction professionals have never been properly trained how to plan and execute lifts safely. And that's where we come in. We do this through two main programs. So our first program, Level 1 Crane Fundamentals. This is the course that if you're tuning in tonight, it's likely the course that you're going to get the most value from, because this starts off at the absolute fundamentals and takes you through to give you a solid knowledge of how lifting activities work. We do also have the Level 2 Lift Specialist course. Now, this course is quite intensive and in-depth. So this course is for people who really want to go next level, and when you have the experience, you can combine this knowledge to get to a position where you're comfortable planning, reviewing, and executing lifts and overseeing those activities. We do deliver it in two different ways. First way is online, and this is a glimpse inside the online platform. And then we, of course, do workshops face-to-face for large teams. So that's it, just introduction to Crane Class. And then just to follow on from that, very briefly, who I am, because you may not have met me before. If you're on the webinar last week, I do apologise. I'll make this very quick, as you will already know who I am. But I started off at a small crane company in Ballarat, Victoria, Advanced Cranes. When I was still in university, I was given a lift plan and said we need to make these. Their biggest crane at the time was a 160, so it was really down in the smaller cranes, in the weeds, out on site every second day, learning from the operators, getting it wrong, and really starting off at that lower level. I then spent a good chunk of time working for CPB contractors on the Westgate Tunnel project, getting the tier 1 side of things. So really involved with safety on that project, so with crane safety, of course, reviewing swims and lift plans, of course, as well as creating lift plans and planning a lot of lifts on that project. Then finally, for the last 4 years before I started Crane Class, I was lucky enough to head up engineering at BMS Heavy Cranes in APAC. BMS, top 5 global crane company, predominantly doing onshore and offshore wind turbines. So got to do with the bigger end of town there, the bigger cranes up to their 3,000-ton ring crane. That's Crane Class. That's who I am. You're here to learn about load charts, so let's move forward into those. Let's start off. So to put simply, a load chart is arguably the most valuable piece of information we need when sizing up a lift. It gives us a few things. It gives us the capacity of the crane, how much it can lift, and we will dive into that exact definition a little bit further in a moment. But it tells us how much we can lift at different radius based on certain configurations. There are two main variations of load charts, and it's very important that you understand the difference between them. The first is short form load charts. The second is long form or serial number specific serialized load charts. And we're going to have a look now at what the differences are between both of those. So first up, we've got short form load charts. These are essentially a sales chart. They give an overview of the crane's capabilities and they can be found in the product guide. So I'm going to show you what the product guide is in a moment, because the product guide itself is essentially a sales guide. It's like if you're going to buy a car, it's the brochure. It gives you all the specs, all the information of that machine. And that's no different with a crane product guide. But we use these a lot when it comes to actually using the machine once we own a crane, because they provide such a good summary of the information that we don't have to carry around 5,000-page manuals of the actual load charts on the machine. This just tells us roughly if this crane should be able to do the job or not. So let me explain product guides. A crane product guide, people call them different things, but some people just call it the brochure, is a short summary of a crane's features and capabilities. It provides the majority of information you would need to assess a crane's feasibility for completing a certain lift. So it includes things like the geometry, different specifications, the available configurations of the crane, accessories that you could put on the end, different counterweight options, often includes the weights of components and some information about road travel, as well as an overview of the hook block options and range charts. Most importantly, the product guide provides us with short form load charts of varying configurations, and this allows us to determine if this crane is capable of lifting a certain load at a certain radius. Now, the product guide itself will always typically have the strongest main boom full counterweight configuration as the very first load chart. And then as you scroll through that, it will provide different configurations, but it'll only provide glimpses. It just provides various options for you to assess the capabilities of the crane, but there is many more options that are not listed in the product guide. Importantly, if you want to find crane product guides, they are all available on the manufacturer's website. So if you go to Liebherr's website and navigate to mobile cranes, you'll be able to find a downloadable of each product guide for every crane that you can get from Liebherr, every crane that Liebherr offer. There is a note there that, because this is out of the course, as part of the course you do get a library full of product guides so that you can easily access them. If you don't have something like that set up, 100% really good to have them set up, because when you're sizing up a lift, you want to quickly be able to jump between product guides. All right. Hopefully not pushing ahead too fast, not losing too many people there, because I'm going to now explain actually reading the load chart. So this is the short form load chart that we see in the product guide. What we've got up the top here, we have information about the configuration of the crane. So there's a few different symbols here, and this is a Liebherr crane, so everyone does their symbols differently. But first up, this is saying that we're on the telescopic boom. The telescopic boom goes from 12.3 meters fully sucked in to 66 meters fully extended. And on Liebherr cranes, T is the code for main boom only, so no attachments on the end or anything else. Saying we're on outriggers, it doesn't really give us much more information, but being the first load chart in the product guide, it's usually a pretty good indication that that is for full outriggers, and it will specify if it's shorter outriggers. This symbol here means 360-degree slewing range, and that's what we always want. If you didn't have that, for instance, you can get load charts that are just specifically for, say, plus or minus 10 degrees directly over the back of the crane, because you get a bit better capacity there. But we want to be able to slew the crane in any region and can maintain our full capacity. Next one is probably the most important thing up here, and that's the amount of counterweight that is on the crane. This load chart is specific to this amount of counterweight. If you add or subtract counterweight from the crane, then you have a completely different load chart altogether. So this chart right here is for 45 tonne of counterweight. If we get into reading the chart, what we've got is down the vertical axis, we have radius. That is the distance from the center of slew. Now, when I say center of slew, that is the center of the crane, the point that the upper structure of the crane will pivot around that 360-degree angle. That's called slewing. And the radius is that distance from there to the hook. So that's how far out we can lift the load. Along the top, we've got boom length. On the telescopic boom, most cranes, typically telescopic cranes, once you get above, say, a 40-tonne machine, the telescopic boom must be pinned to gain its full capacity. Now, I'll explain that a bit further in a moment. Let me come back to it. But essentially, these are the various lengths that telescopic boom can be pinned at. And that's why it provides these options. So along the top, we've got boom length. So if I choose 28.8 meters of boom and I come down to a 10 meter radius, what we've got, 28.8, 10 meter radius, 43.6. What that is telling me is that the capacity of the crane with that boom length at that radius is 43.6 tonne. If I was to use a slightly shorter boom length, 24.7, we gain a tonne of capacity. We're at 44.6 tonne. 44.6. If I was to use a slightly longer boom length, we go down to 42.8 tonne because more deflection, the boom is less structurally strong, you could say. So that's the basics of how the load chart capacity table works. If there's any questions there before I move on, because we're going to step this up now, if there's any questions, feel free to hit me. Otherwise, I will. Otherwise, I'll keep moving forward. All right. Next up, what I'm going to show you is the long form load chart or the serialized load chart. The reason we call it serialized is because it's serial number specific to that crane. That means that even if you have a Liebherr LTM 1250-5.1 in your fleet, or you have two of these cranes in your fleet, they will have different serialized load chart manuals. I've got to be careful here, but in 98 to 99% of scenarios, they will have the exact same charts. but there are occasions where they do vary slightly due to updates that do come through. But don't stress about that for now. So what the serialized load charts give us, it gives us similar to the short form, but this is everything we need. This is the actual load chart that we use to develop the lift plan. It's the load chart that the crane operator gets in the crane. So it is essentially the Bible that we need to run by. What we have is up the top, we got the configurations again, and now they're more in depth and clearer for us. So we got 43 ton of counterweight. The counterweight radius is out at 5.6 meters because this crane has two options for that counterweight to sit at. Our outrigger span is now listed 9.3 by 8.3 meters. So that's clear. We're on full outriggers. We've got 360 degree slew, and the chart is for a wind speed of 11.2 meters per second. So it's even given us that here as well. Same thing, we've got radius down the vertical and boom length across the top. But there is one really important thing that you're going to notice here that differs from the other chart. What that is that we have multiple columns for the same boom length. You see this 17.4 meters, I've got 1, 2, 3, 4, 5 different columns for the exact same boom extension. So the question is, why is that? Now I'll come back to this page, but let me explain that right now. So we're going to explain telescopic boom configurations. Let's take the Liebherr LTM 1250-5.1, a 250 ton crane. This crane has a telescopic boom with 5 sections. That means that there's 5 boom sections all telescoped inside one another inside the housing. Each of these sections can be extended and pinned at 0%, 46%, 92%, or 100% of its available length. And that's exactly what's shown here. Here the boom's fully sucked in, or everything is at 0. Here we've got the top boom section and extended it 46% out. We've then, here, that same boom section, we've extended it another 46% and it's got 92% hanging out. We can also go slightly further, and that's now 100% of its available extension. This can be done for every single one of these 5 boom sections. So if we take 26.01 meters boom length, for example, this has 11 possible configurations of telescopic section extensions that can provide this length, 11 different configurations. I've shown 3 out of these 11 examples right here. So at the left here, what we've got is 46%, 46%, 46%, 0, 0 extension. And that is how we would list that right here, going from the bottom up. On the next one, we've got 46% out, then 92% extension, 0, 0, 0. Here, 92% extension, 46% extension, 0, 0, 0. Every one of these creates a 26.01 meter boom length. And you might be thinking, well, why does it matter? What's the difference? The difference is because each of these configurations provides a different load chart and a different capacity. So if I go back to this table, I don't have the 26 meter chart here, but for 17.4, if we look down here, this gives us this telescopic boom sequence. Now, the 5th section is actually the top. It can be a little bit confusing. So what that's saying here is that we have the top section extended 46% and everything else at 0, 0, 0. That's for this column. You then go to the next column. It's got the second section from the top extended, but everything else at 0. And then you can see why when you have a longer boom, it gives more possible configurations. So that's the difference between short form load charts and long form load charts that the long form, the serialized load charts take into account the telescopic boom configurations. And something I didn't say earlier, but I should have, is that the short form load chart, for instance here, if I take 20.6 meters, that has just given the best capacity that is possibly available with any configuration that makes up 20.6 meters. So the configuration that provides 73.4 tonne with 20.6 metres of boom might be a different configuration to the one that provides 21.4 at 18 metres with that same length of boom. So that's why it's really important that we go the step further and get the right configuration for the lift. All right, that's quite a bit of information. Sorry, Craig, I do see your comment there. You need a magnifying glass, and I apologise, it is a little bit small. You will be able to get the recording of this on YouTube and blow it up a bit bigger afterwards as well, if that helps. So we're pretty much through the main portion, guys, of reading load charts, but now I'm going to run through an exercise with you and show you actually how to size up a lift and see whether a crane has the capacity to perform a lift. First up, what I want to point out, capacity is the total weight that the crane can lift. That means you need to consider a lot of things. It's not just the weight of the load. It's the weight of the hook blocks, the weight of the rigging, the weight of any stowed components or additional components, such as over here, we've got a short runner that allows us to have a secondary hook block, an auxiliary hook block. The weight of the winch rope of the auxiliary hook also needs to be catered for. The weight of the winch rope on the main, that is specific to each crane. Most cranes these days do cater for it in the load chart, and you don't need to do it yourself, but you need to be certain that that is the case, because other cranes such as Sannies, you need to add the winch rope there. Point being that the capacity is everything. So it's not just the weight of the load, you need to consider a lot of other factors. All right, here's our exercise. Imagine you get a call. We need to lift a 5-tonne concrete segment at a 20-metre radius. That's all the information you really provided. We're not worried about how high up it's got to go, how much boom length we need, if it's got to get over any obstructions, just weight and radius. We're trying to narrow down what crane could possibly do this lift. So what you need to consider, I'm going to give you a couple of things here. So let's say we'll make a judgment for a 1.5 tonne hook block, half a tonne of rigging, and this site restricts the crane's utilisation to 90%. So we need to perform a tiny bit of maths here. I'm just going to have a drink of water, but hopefully you don't need your magnifying glass for that bit, Craig. Hopefully we can see that. Excuse me. All right. What we've then got here is the maths to add this up. So we've got a 5-tonne load. We're going to add the 1.5 tonne hook block and half a tonne of rigging. We're going to need then 7 tonne. But we want to stay under 90% utilisation. So what we do is we get that 7 tonne and we divide it by 0.9. That gives us approximately 7.8 tonne. What that is then the chart capacity that you need to be able to perform this lift. So we need to find a chart that can provide 7.8 tonne capacity at a 20-metre radius. So let's get stuck into doing that. You need to start somewhere. So you need to choose a crane that you think might be in the ballpark, and you'd usually choose cranes that are either in your fleet or that you know you have access to with your contractors. Let's start with an LTM 1200 here. This is a 200-tonne Liebherr crane. So we go into the product guide, we scroll down to the very first load chart because that's our strongest main boom configuration of this crane. What we want to have a look at is we want to go down to 20 metres radius and go across and see just what the best capacity is with any boom length at that radius. This crane, if you can't see that, that is 29.2 tonne capacity at 20 metres radius, and we only need 7.8. So we've shot a bit high here. So we're going to start working down crane sizes. Next crane in our fleet might be a 160. Same thing, we go to the very first load chart. We have a look at 20 metres radius. Any boom length? This crane's best case is it can do 17.8 tonne at 20 metres radius, so 10 tonne more than we need. We're going to then take a bigger step because we go, all right, we're still well out of the ballpark, but we might have a 4-axle 100 tonne crane in our fleet. So we get to the load chart for that. First load chart, 20 metres radius, it can lift 11.6 tonne. All right, we're getting closer now. So then the next question is, well, do we have a next size down crane? So let's say we've got a 90 tonne crane. We go to the 20 metre radius, go across, we can lift 9.4 tonne at 20 metres radius with our 90 tonne crane. So we're still above the capacity we need. Do we have a smaller crane in our fleet? Maybe we just go and check that. So let's say you've got a 70 tonne crane. Do the same exercise, 20 metres radius. Okay. The 70 tonne crane can only lift 6.4 tonne at 20 metres radius. The 90 tonne crane can lift 9.4. You can be over capacity, but you can't be under. So what that says is that this is a 90 tonne crane job. Unless you've got anything else in between there that might get the job done, the 90 tonne crane is the right crane for the job. And that's this typical process you'll do when you're sizing up a lift if you're in sales or if you're just working out on this job site roughly what size crane you need. Now, there is a second step to this. You can then start to look at the counterweight on the crane and if you can save a little bit of money. So this is an extract from that page on the 90 tonner. The first load chart, we've got 21 tonne of counterweight. Can lift 9.4 tonne at 20 metres. Directly under that, it's given us a chart for 17 tonne of counterweight. We can lift 8.6 tonne at 20 metres then. So what that's telling us is that we could still do this lift with only 17 tonne of the 21 tonne counterweight that this crane can take. Now, this isn't the best example of this because where I'm going with this is that you could save with some mobilisation on sending all of that counterweight to site, the time to load it on, but mainly the trucks back and forth. On this crane, 21 tonne of counterweight is going to go on one truck anyway. So that extra 4 tonne slab is going to be there and you really may as well use it and have a bit extra capacity up your sleeve. But if this was a 250 tonne crane, for example, that has 4 truckloads of counterweight that typically follow it, and you can reduce your 88 tonne of counterweight down to, say, 68 or 58 tonne, that's saving one whole truck of counterweight, which might be $1,000 each way. It depends how far you're traveling, and can really be a good cost efficiency that you could be looking for. Now, I've got one more bonus tip there as well. Of course, if you're at a crane company and you only had a 100 tonne crane in your fleet, for example, of course you could send it to do this job. What you would do and what would be fair by the customer is to agree to only charge the rate of a 90 tonne crane for this lift because that's what crane could do this lift and that's probably what your competitor could provide. You would then assess it with your 100 tonne machine and see if you can do any of those counterweight savings if possible. So that's pretty much the rough exercise of sizing up a lift. I've flown through that pretty fast, but this recording, as I said, will be available on YouTube if you did want to go and watch it and listen to it a bit slower later. But that's just the rough process of reading a load chart, understanding telescopic boom configurations and the differences between the different configurations, but the short form load charts and the long form load charts. All right. Well, I really hope that you got some value out of that. If you did, please I think you can give us a thumbs up or something. Let me know, or let me know in the comments. I'm going to just take a few more minutes now. I'd really love if you could stay on the call and I can just show you this level 1 crane fundamentals course that'll be available at the end of this month. It starts off really where we did today and even back a bit further, because this is the course that is designed for tier 1 project teams and specifically for graduate site engineers, health and safety teams, to really get a grasp on how cranes work. It's aimed at teams, but you can, of course, do it as an individual 100% online. It's available from the end of the month, but we do have a wait list now. And if you jump on that wait list, there's some specific bonuses that you will get if you then sign up on launch day. I'll take 2 more minutes, and what I actually want to do, if it's going to let me, is show you inside the course, because it's actually really cool inside the platform. And I'm just going to show you here. This is what we've got for the level 1 fundamentals course. You can work through it fully online within this platform. You see, I go to Mobile Crane Deep Dive, which is our 3rd module. And we've got all of these lessons on a mobile crane. You see, we've got this whole lesson here, for example, on telescopic boom configurations. 13 and 14 minutes going through that using Liebherr's 3D crane planner to really pull all them boom sections out and show you everything. That's just one little lesson. You've got counterweight, outriggers, how to mobilize a crane. All of these things are included in the level 1 crane fundamentals course. So if that is for you, feel free to ask me any questions about it or hit me up. But scan that QR code, click the link, jump on the wait list. Otherwise, if it's not for you, feel free to stay up to date with any of these upcoming sessions. I do certainly intend to do more of these going forward and try and just help out our community as much as we can. Otherwise, if you enjoyed tonight, please let me know. Feel free to share it with anyone in your team who it would benefit. Are there any questions? Guys, I forgot to ask that. Did anyone want me to clarify anything that I went through tonight? Nothing necessarily coming through, guys. If that's the case, let's leave it there. I really appreciate you all jumping on tonight. Thank you for your support. And I'll see you in the next one.